When calculating voltage drop for an extended circuit, the calculation starts from the original subpanel. Let's consider a scenario involving the relocation of a spot and the associated voltage drop concerns. The existing spot is approximately 80 feet from the panel, fed by a 50 amp circuit using number 6 conductors. The relocation involves moving the spot an additional 110 feet from its current location. Due to existing conduit and panel limitations, upgrading the wire size to number 4 is not feasible. The primary concern revolves around managing voltage drop effectively. The strategy is to install a breaker panel at the existing spot disconnect location and extend the circuit with 110 feet of conduit using number 6 wire. We will determine if this eliminates the voltage drop issue or if the calculation must begin from the original subpanel. Remember, the voltage drop calculation always starts from the original subpanel. To calculate voltage drop, we'll use the formula voltage drop equals current in amps times circuit length in feet times resistance of wire per 1000 feet. In this situation, we are making the following assumptions. The spot draws a current of 50 amps. The wire size is number 6. The wire resistance for number 6 wire is 2.41 ohms per 1000 feet. The additional conduit length is 110 feet. To find the total circuit length, we add the original length of 80 feet to the additional length of 110 feet, resulting in a total circuit length of 190 feet. To find the voltage drop for the original circuit, we use the voltage drop formula. Voltage drop equals 50 amps times 80 feet times 2.41 ohms divided by 1000 feet. This gives us a voltage drop of 9.64 volts for the original circuit. To determine the voltage drop for the additional conduit, we again apply the voltage drop formula. Voltage drop equals 50 amps times 110 feet times 2.41 ohms divided by 1000 feet. This calculation results in a voltage drop of 13.26 volts for the additional conduit. To calculate the total voltage drop, we combine the original voltage drop of 9.64 volts with the voltage drop for the additional conduit, which is 13.26 volts. This results in a total voltage drop of 22.9 volts. The total voltage drop for the new circuit with number 6 conductors is 22.9 volts. This exceeds the allowable voltage drop of 5%, which is 14.4 volts for a 240 volt circuit. To eliminate the voltage drop problem, upgrading the wire size to number 4 conductors is necessary. With number 4 conductors, the voltage drop is calculated as follows. Voltage drop equals 50 amps times 190 feet times 1.58 ohms divided by 1000 feet. This calculation gives a voltage drop of 14.34 volts. This figure is within the acceptable range. I recommend installing a new subpanel at the original spot disconnect location fed by a 50 amp circuit with number 4 conductors. Then run the new conduit and number 4 conductors to the new spot location. This approach provides adequate voltage to the spot without exceeding the allowable voltage drop.